The sun is 880,000 miles in diameter. It's 93 million miles away, but it still casts a shadow on the Earth. In fact, there's two shadows. One's the umbra shadow, which is the deep shadow, and there's the penumbra shadow, which is the not so deep shadow. And this is why you see more startling objects at right after sunset and right before sunrise. If you look, I put a little arrow stick on the circumference of the Earth, two of them. So say you're right there, and you look up, you can see Starlink. Now there's a red circle and a blue circle, which represents low Earth orbit. So the blue circle was the original Starlink orbit, which was recently reduced to the red circle. This all is into scale. But you can see that the closer you get to Earth, the less time you're going to have to see anything that's reflecting sunlight, which Starlink satellites do. So the closer you are to sunrise or sunset, you're going to see the most, but then you're going to have not dark skies. You're going to have a twilight, which is going to wash out these dim things. So you got to keep that in mind. Now, if you're at the arrow stick that's on the Earth's circumference and you're in a straight line between the sun and Earth, well then everything is going to be blocked by the umbra, unless it's a high or low inclination orbit. This is assuming orbits around the equator. So that's why sometimes, suppose like you are facing east and you're recording something, right? And then that means the Earth's shadow is towards the west, the dark shadow. And you could see like Starlink or other unidentified flying objects. Well, it seemed to appear out of the middle of the sky because they were still in the Earth's shadow, and it moved out of the shadow, say from the umbra to penumbra, and voila, you could see these things. And that's how it works. Now, HEO stands for high Earth orbit, and you can see those things much longer because they're further away, and they're illuminated by the sun more before it gets into the Earth's shadow. That's pretty much how it works in a nutshell. There's more to it. Like I said, the inclination of the orbits, are they sort of heading towards the North Pole? Since I live in the Northern Hemisphere, it have to have a high inclination orbit that takes it over to Earth's North Pole, and it would tend to be lit by the sun's rays longer than if it was going around the equator. And conversely, it would be the opposite if you lived in the Southern Hemisphere. And that's how it works. But I noticed that the Starlink can go from east to west or west to east or from north to south or south to north. They changed their orbits. I don't know, I guess the AI is programming these orbitals for the best coverage or whatever you may call it. But in a nutshell, this is how it works. All right? So if you put your camera out or you go out too early or too late, well, you're going to miss a lot of Starlink. Starlink happens right at the interface of when the sun is just below the horizon, but we're still in the shadow, as pointed out by these arrow stick thingies on the Earth's circumference. This time-lapse video was taken on January 13, 2026 between 4:53 a.m. and 6:20 a.m. This is sionyx aurora. This is the green model. They discontinued the green model because it has this green accents on it. I think I paid like $4.50 for it. Okay, so then I realized that I wanted to have two of them so I could point them adjacent to each other and get some overlap or just get more coverage in any night sky. And I added the raynox wide-angle conversion lens to it also. Now I also got the black one, and I only paid $300 for it from B&H. I got them both from B&H's Superstore in New York City. And, but now I see the prices are like between $700 and $800. So if you're interested in one, you just got to shop around and don't buy it right away. Like, just keep checking the prices and they have sales or something. So I guess I got lucky. Um, is this really night vision? No, it's low light level videography. But for the stars and the night sky, it's excellent. It captures the Milky Way. It can get these little dim moving dots, these starling things or UFOs. It will capture meteors without any trouble. Meteors, fireballs, bolides, jet planes, airplanes, I guess drones if they're lit up, all that stuff. It's great. But like I said, wait for it to go on sale or buy used. Um, it is grainy. I had to shut the color off because in the sky it was blotchy. It's good for urban settings and dark streets where you could see a thug hiding behind a lamppost or something. But I don't use it for that. I use it for the night sky. I found it totally adequate. It takes it comes with a battery. It can put a 64 gigabyte micro SD card in it. It's supposedly waterproof, but I never looked into that. But I guess you can leave it out in the rain. You don't have to worry about getting ruined. What are its other main features? It does 7.5, 15, 30, and 60 frames per second. I think it has a super fast slow motion mode, which I never used. It has a digital zoom. The digital zoom is good when you put your wide angle conversion lens on it. I give it one click up to get rid of the corner vignetting. It has an f1.4 lens. It stops on the f5.6 for daytime, but for daytime, infrared block filter gets in the optical path, and it works really good for a daytime camcorder. But for the purposes of just looking for things in the night sky, it's really great, and it's small. It's a palm quarter. It has an adjustable viewfinder. It has Wi-Fi. It has GPS. I shut all that stuff off because the battery life is short. There's no getting around that. So on January 13th, 2026, I captured some video of the night sky, and there wasn't as many Starlink as I used to think because they lowered the orbit. So you gotta get closer to sunrise to see as many. Plus, there was a train. There's a train of these things went. You'll see it in the video following. There's a train of these dots coming down. Was that Starlink? I don't know. They're supposed to add another between 7,000 and 9,000 more Starlinks to the constellation. So they got that going for it. It's just interesting. I bought this camera to do a meteor and bolide study, and I end up I'm doing a Starlink study instead. But it's interesting to see how the night sky changed from nothing to all this stuff flitting around in the night sky, which you will see following. So this is fast forward. It skipped 2 frames, recorded 1 frame. And then when it interlaced the video, it went from 7.5 frames per second to 30 frames per second. So it really sped the living daylights out of it. Now, these small, dim lights that you see moving, those are Starlink. The brighter lights, they may be airplanes or jets, but they could still be other satellites. That's probably an airplane. Now, they lowered the orbit of Starlink from like almost 500 to less than 300 miles. So that means that they're all closer to the Earth. That means they're going to be into the Earth's shadow quicker. So there's somewhat less than there were like a week ago, But they're going to add between 7,000 and 9,000 more Starlink satellites. Every time I read about it in the paper, they say one number, and then 3 days later they put out another number, like they changed their mind or something. Plus, they want to add another 20,000 Starlinks to the constellation. So as of right now, Starlink has the most. See, look at them all. We're getting closer and closer to sunrise, so we're going to start seeing more. But then, as you get close to sunrise, the sky brightens up, and it's sort of, eventually the sky is bright enough that these things. Oh, look, there's a train. Now, see how quick that train went by? Well, this isn't fast forward. What we're going to do is we're going to see that train in real time, following this video right away, just to give you an idea that they do appear to move slow. They're moving at like thousands of miles an hour in their orbit, but because they're covering such a vast amount of sky and they're 300 miles away, that masks their quick movement. There's no getting around that. So you got to keep that in mind. Everything's an optical illusion. Here's the Starlink train in real time. I was just using this free Cutter software, and I go like 15 seconds ahead. You see that one that just came off the top? That's part of the train. And that's pretty much how slow they would move. I keep saying it where I live, there's a lot of sky glow. And even if I have this sionyx aurora camcorder out, and I just set it up, and I look up in the sky, I don't see anything, and I look in a viewfinder, I'll see that dot. That's how bad the sky glow is. And these things are really dim. Plus, they're probably reflecting the sun's infrared rays, which my eye isn't sensitive to, but the camera is. So you see these dots, how slow they move. Can you imagine if I had like a 90-minute video of these dots moving so slow? No one would watch it. But I just want to did this on purpose because it is a Skylink train, I would assume. And how come one or two are brighter and the rest are dimmer? What's up with that? Look at that. There's a whole slew of them coming down. So, and you never used to see this stuff. This is all a recent phenomena. I've been watching the sky in my location here for almost 40 years. And I watched the sky glow get worse and worse. I used to be able to see the Milky Way. Not spectacular, but I used to be able to see it. And now it's cannot be seen except in an instrument. Starlink progress,